video is about the properties of real numbers. We'll go through each one of the properties and define what it means and show you an example of them. So the first property is the commutative property of addition. Symbolically, we might write this as a plus b equals b plus a. So for any real numbers a and b, it is true that whether you add them in the first order or the second order, the values of them are the same. So for example, 3 plus 5, both real numbers, equals 5 plus 3. Is this true? Of course it is, because 3 plus 5 is 8, 5 plus 3 is also 8. So that's the commutative property of addition. Commutative property also works for multiplication. We might write this as a times b equals b times a. It's the order that is changing. The operation is staying still as multiplication. To show that with numbers, is 3 times 5 equal to 5 times 3? Of course it is, because 15 does equal 15. So the order in which you multiply does not matter. The associative property of addition. So associative property, symbolically, we might write it as a plus b in parentheses grouped together with a plus c on the outside, is the same as grouping the b and c together in the parentheses and putting the a on the outside. So it's all addition, and that's very important. Associative property works for addition. If I threw a subtraction sign in there, the associative property would go out the window. So for addition, it is true to add two things together in the parentheses and then add the third, or to add the second and the third together in the parentheses and then add the first. So let's show this with numbers. Is it the same to say this as to say this? I'll actually do the math out for this one so you can see. Parentheses, you have to do what's inside them first. So if I add the 5 and the 4 first, I'm going to get a 9. Versus on the right side of this equation, if I add the 3 and the 5 together first, I'm going to get an 8. If I finish simplifying, however, on the left, 3 plus 9 is 12. And on the right, 8 plus 4 is also 12. So we went about it in different orders. Because of the associative property, they came out to be the same. Associative property also works for multiplication. So if I do a times b in the parentheses and then multiply by a third number c, I'm going to get the same thing as if I do the b times the c first, and then put the a on the outside and multiply that third. So to show this with numbers, 3 times 5 times 4, is that the same as 3 times 5 times 4? Show if it works. On the left, we have 3 times the quantity 5 times 4, which is 20. On the right, we have quantity 3 times 5, which is 15, times 4. And sure enough, 6b equals 60. So the associative property of multiplication is true. The distributive property. You're probably familiar with this one. Symbolically, it's written as a times b plus c. So this is the first time we've got multiplication and addition in the same property, equals ab plus ac. So it's distributing the a, right? Distributing the multiplication. Showing this with numbers, it might look something like this. If you see an expression like 4 times the quantity x plus 5, it is true for you to say 4 times x plus 4 times 5, or 4x plus 20. That's the distributive property. Identity property of addition. So think about the word identity, right? It is who you are. So the identity property of addition says that if you are the number a and you want to stay as the number a, what do you add to yourself to stay as the number a? You add the number 0. So a plus 0 equals a is known as the identity property of addition. To show that with numbers, 4 plus 0 equals 4 would be an example. What about the identity property of multiplication? If you are the number a and you want to stay as the number a, what do you multiply yourself by? And that number is 1. So for addition, it was 0. For multiplication, it is the number 1. To show that with numbers, 4 times 1 equals 4 would be an example. Then we have the inverse property. The inverse property of addition says, what do I have to do to a? So let's say I am the number a. What do I have to do to the a to get the identity? So if you remember the identity for addition, it was 0. So what do you have to add to an a to come out with 0? The answer is negative a. It's basically like the opposites, or, well, the word inverse, it does kind of mean opposite. So a plus a negative a is going to result in 0. To show this with numbers, it would be like 3 plus negative 3 equals 0. That would be an example of the inverse property of addition. 3 and negative 3 are inverses. Inverse property of multiplication So if you're starting out with the number a and you want to get the identity for multiplication, well, remember what the identity for multiplication is. It's the number 1. So what am I going to have to multiply a by to get the number 1? It can be a little bit trickier than addition, right? The multiplicative inverse, it's called, of a is 1 over a, right? They're basically reciprocals of each other. To show that with numbers, 3 times 1/3 would be 1. So 3 and 1/3 are multiplicative inverses of each other. Showing some examples, what you might be asked to do is describe which properties the following examples demonstrate. So when we're looking at that first one, I see a -3 being multiplied by a 1, and it's staying as -3. -3 staying as -3 makes me think of identity. Because this one is multiplication, this must be the identity property of multiplication. And it is important that you write out the of multiplication part. Next example, I see parentheses. That immediately makes me think associative property, but this one is a trick question. Look at the parentheses and what they're grouped around. In both examples, they're grouped around the 2 plus 3. It is not the grouping that is changing here. What is changing is the order of the 2 and the 3. The 1 is staying outside on both the left and the right side of the equation. So don't get fooled by things like this. When the order changes, but the value doesn't, that's called the commutative property. Commutative property, and this one is of addition. The next example, I see a 3a outside of a parentheses, a b plus 2c inside, and it's pretty clear that that 3a is getting distributed. This is the distributive property. And then in this last example, I have 5 plus a -5 equaling 0. So I see a 5 and a -5, and I'm thinking those are opposites of each other. But they're only opposites of each other in terms of addition, right? So this must be the inverse property. Inverse is a word that pretty much means opposite. Inverse property of addition. That is all.